Alright, so now this is going to be lesson 6.2. We're going to go over those properties of our exponents again, and then how that changes when we're doing it with our rational exponents a little bit. So our rules all apply still. We have our zero exponent, anything to the zero power is 1, negative exponent, that's the one we learned last lesson. When we have the negative here, we take that reciprocal and it's to the positive now. Now products, remember we should add our exponents. Quotients, remember that's our division. That's when we subtract our exponents. Now don't forget that power of a power. That is when we'll multiply those exponents. Now, we're going to learn two more. Power of a product and power of quotient. If I have two things multiplied, like we do here, and they are both to a power, well then I can write them separately to the same power. So an example of that would be like if I have a 3x here and those are both cubed, well that's the same as a 3 cubed times an x cubed. One last thing we can do is, well, 3 cubed is 27, so this would be a 27x. Now our quotient rule works the same way. When I have two things divided here and they're both to the same power, I can split that power up into each of these two things. So what we're going to do here, if I have, let's say we do that 3 over x and that is all cubed, well then I would have a 3 cubed divided by an x cubed. Last thing we do, simplify that 3, 27 over an x cubed. Okay, so for example 1 here, what we're going to do is we have this 7 to the 1/4 times a 7 to the 1/2. This is our product of powers. We're adding them together, so we should have a 7 to a 1/4 plus a 1/2. That gives us 7 to the 3/4 power. Well, we can rewrite this one last time. That's what we learned in lesson 6.1. So this is really the 4th root of 7 cubed. Okay, so for B now, we have 6 to the 1/2 times 4 to the 1/3, and those are both squared. So this one is going to be our power of a product here. I have an A, I have a B, and these are both to the 2nd power. So what we're going to do is we're going to say, okay, well, they're both to this power. Remember, that's going to also be our power of a product now. So we'll have 6 to the 1/2, and that's squared, times a, sorry, not 6, a 4 to the 1/3, and that is squared. Now that's where our power of a power comes in. We're going to multiply those exponents. Well, 2 times 1/2 is just 1, so we have a 6 now, times 4 to the 2/3. If I simplify this here, we will now have 6. We're going to have a cubic root of 4, and that 4 is going to be squared. What we could do is we could also put this exponent on the inside, and we could say this is 6, the cubic root of 16, because I square that 4 on the inside there. Okay, now for C, we have 4 to the 5th times 3 to the 5th, and that's in parentheses, and that's to the negative 1/5 now. So this is still that power of a product rule. This power will affect both of these terms on the inside, so we'll rewrite it with that first. We'll have 4 to the 5th raised to the negative 1/5. And this is the 1 in there. That will be multiplied by 3 to the 5th to the negative 1/5. So when we do this, we multiply our exponents here, so we now just have a 4 to the negative 1 times a 3 to the negative 1. Well, they're both a negative 1, so when we have a negative exponent, we flip it upside down, so we now have a 1/4 times a 1/3, which is a 1/12. Okay, so for D, we have 5 divided by 5 to the 1/3. This is going to be one of our quotient rules. This is where we subtract our exponents. So this is where we have 5 to the 1 minus a 1/3. That's going to be the same as 5 to the 2/3 power. And now here we can rewrite it a little bit. This is going to be the same as a cubic root of 5 squared. Last one we have here, E. we now have our power of a quotient rule. The squared is going to affect both of the terms that we see here. So, what we also could do is say, well, 1/3 affects both of these terms here. So we could do the opposite. We could say, okay, well, if I have a to the m over b to the m, well, m in this case could be our 1/3. I could take this out as well. So another way we could rewrite this is 42/6 to the 2/3. Because remember, we multiply our exponents when it's a power of a power. Multiply that through, we'll get 2/3. So now here, we have a 7 to the 2/3. Last thing we can rewrite this, well, this is a cubic root of a 7 squared. Because remember, that square can go on the inside or it can go on the outside. So the cubic root of 49. Okay, so we're going to go through some more properties. This is our product property and our quotient property. When these are multiplied, we can also split these apart when they're in our radicals, just like we can with our exponents. What we can't do is do that when they're added, though. So a common thing you want to look out for is if I have the square root of an a plus b, remember that's not going to be equal to that root a plus root b. This is true for anything, so this is not just our square roots, this is any root we have here. If you don't believe me, you can check this on your calculators. If you plug in the cubic root of, say, like 2 plus 6 here, well, that's going to be the cubic root of 8, which I know is 2. But if I plug into my calculator the cubic root of 2 plus the cubic root of 6, well, that's not going to be a very nice number. So if you go on your calculators and you type in that cubic root here of 2 plus that cubic root of 6, well, you're going to get around a 3.077. Not the same thing, so make sure you're only applying this to things that are being multiplied here. Now for our quotient rule, nth root of a over b is equal to the nth root of a divided by the nth root of b. I can split these up as well, so my radical can split when it's division as well. So if you look at our example 2, we have the cube root of 12 times the cube root of 18. Well, since these n match, I could actually combine these together. This could look like the cubic root of a 12 times 18. Well, if I have the cubic root of a 12 times 18, that's going to give me the cubic root of 216, which actually simplifies down pretty nicely. That's just going to be a 6. For our next example here, we have the fourth root of 80 divided by the fourth root of 5. Well, they're both a fourth root. They're in a quotient. Since they're both 4, we'll just say that, well, this is the same as the fourth root of 80 over 5. Well, 80 divided by 5, that gives me a 16. Fourth root of 16, well, that's just a positive or negative 2. Don't forget, when your n is even, like it is here with 4, you have to have your positive and your negatives when you simplify. So positive and negative 2 here and a 6 here. Okay, so flip your pages over. When it says to write in the simplest form with these radicals and exponents, it means we don't want anything that doesn't have a perfect nth power in it. So what that's saying is if I have the cubic root of an n to the 5th, well, there's technically an n to the 3 in there somewhere. So we want to make sure we're taking anything that we can outside of that radical. So then we would just have an n cubic root of an n squared for that one. We also don't want our radicands to contain fractions on the inside, or for them to be in the denominator of a fraction. So like if we look at example B, we're definitely going to have to rewrite that because we have that radical in the bottom. For example A though, it's a little harder to see. We have the third root of 135, which if we type that into our calculators, we're not going to get a very nice number out. So if we go, okay, well what's the cubic root of 135? Not a nice number. But we can simplify this still. The way we're going to simplify that is saying, well, what can I divide by 135 by? Okay, well 135, I can divide that by a 5. When I divide that by 5, we're going to get out a 27. Well, 27, that's a 3 cubed. So I could rewrite this. I could say, well, this is now the cubic root of a 3 cubed times 5. Well, now I can follow my product rule. I can split those up. I have the cubic root of a 3 cubed times the cubic root of 5. Well, that can't simplify at all, but this one can. I have the cubic root of 3 cubed. That cubic root and the 3, those cancel out. So this is just a 3, the cubic root of 5. So whenever we have the same nth root and exponent, they're all going to cancel out and just leave whatever number we had on the inside left. Okay, so if we look over at B, we have the 5th root of 7 and the 5th root of 8. Well, what we can do is we can say, okay, well, I see that the 5th and the 5th, those are the same. I could potentially rewrite those. But there's no nice 5th root of 8. And I don't want to have a fraction inside my radicand either. So rewriting it doesn't help me too much. So what I'm going to do is I'm going to say, okay, well, what could I do to get rid of this on the bottom? Well, over here, when I had a third root of 3 cubed, I was able to get rid of my radical. So what if I come over here and say, well, what happens when instead of rewriting, I multiply by something? I'm going to multiply by a 1, but I'm going to write it in a way that helps me change how this looks. I need 5/8 in order to cancel this out. Well, I already have 1, so I need 4 more. But I need it underneath that same radical in order to combine them. But anything divided by itself is still 1. So I'm multiplying by 1 here, but it's going to let me get rid of that radical in the bottom and rewrite my equation. So from here, we would have a 5 root 7 times a 5 root 8 to the 4th divided by, well, now I have a 5th root of 8 to the 5th. Those cancel each other out, leaving me behind with an 8. So this is equal to the 5th root. I'm going to combine these two here. I have a 7 and I have an 8 to the 4th. So 7 times 8 to the 4th divided by an 8. Now, if I have an 8 to the 4th here, there's technically not a 5th with that 8. But I do know that 8 is actually 2 cubed. So I'm going to rewrite this one more time. What if I have the 5th root of 7 times, instead of writing 8, I'm going to put that 2 cubed to the 4th. Now we follow that product rule. Well, I have the 5th root of 7 times 2, and that's going to be to the 12th power now. Well, now there's groups of 5s in there. I could have 2 to the 5th times a 2 to the 5th times a 2 squared, all over 8. Because remember, 3 and 4, that multiplies, that's 12. I should have 12 2's in here. Well, 5, 10, 11, 12. I have 12 2's now. So that means I can take 2 2's out. So, if I take 2 2's out, we'll have a 4 8's. That'll be 1/2. Then we'll have the 5th root of a 7 times a 2 squared, or 4. So the 5th root of 28. So last thing, 1/2 5th root of 28. Okay, So that's where we're going to leave it off for 6.2 right now. So if you look here, we're going into conjugates after that. There is some practice if you flip these over. And then one more time, there are 2 full practice pages with this stuff. This will be more on things we do next lesson. So that first page, page 10, is where that practice for this lesson is going to be. So if you want to practice some of these, look at page 10 of your note packets now.